Hello, I'm Greg Snalga. I'm from New Zealand. I'm currently living in Tokyo, and I'll be your teacher for the Culture and Physics course. So, this course explores how a scientist's cultural background affects his or her interpretation of a physical phenomenon. It contrasts the mainstream Western scientific viewpoint with that of the Eastern or Vedic viewpoint, and introduces the ways in which experiments on subatomic particles are recently forcing Western scientists to adopt that Eastern viewpoint in order to make sense of the results. So what is physics? Physics is the study of empirical objects and their motion through space over time, with empirical objects being objects of observation that we can see, hear, and touch. So you've got lightning here, and a galaxy, spinning top, and a nuclear explosion. These are all kinds of physical phenomena which are studied by physics. So the first lesson, lesson 0, this will be basic psychology for physics. So before you can study physics, you have to understand some basic psychological ideas, starting with object permanence. Do objects continue to exist when they go out of sight? Subject-object dichotomy. The viewer, observer, we're the subject and we're looking at objects, so that's kind of splitting the universe into two different parts. And the theory of mind. And the second course will be basic algebra for physics. So if you want to do physics, you need to be able to do some basic formula manipulation. For example, here we've got mass times acceleration times displacement equals work. So all that we're going to learn to do is how to change it so that you've got mass at the start. So mass equals work divided by acceleration and displacement. So the next course will be basic statistics for physics. Physics is very statistical. A lot of the fundamental phenomenon don't make much sense from an everyday perspective, so we have to look at the statistical properties which lead to our everyday experience, like the law of averages. And here we've got Maxwell's demon demonstrating how the law of thermodynamics. And next you want to look at some basic geometry. So from the psychology lesson we learned that the most fundamental definition of an object is a two-dimensional shape which moves across your field of vision. It's translated from one position to another, and it could also be seen to rotate or enlarge or become smaller as it moves into the distance, and yet the child considers it to be the same object. And the next lesson will be everyday physical phenomenon. Here we've got a guy on a motorcycle crashing into some tires, and the bike stops, but he keeps moving. This will be the law of conservation of momentum and inertia. And we'll also look at things like temperature, weight, length, and time in everyday situations. The next lesson will be Newtonian physics, the physics of Isaac Newton, and we'll look at his 3 laws, including his law of the definition of inertia, the definition of what force means, and how all actions are interactions. So here we see 2 ice skaters. If one pushes against the other one, both of them will move evenly backwards in both directions because all actions are interactions. Okay, the next lesson is about relativity, specifically Galilean relativity, the theory of Galileo Galilei, and we'll explore the concept of absolute versus relative. And here we've got a picture of a ship which is moving at velocity v, and yet 2 people in the galley of the ship can play tennis and they don't even have to think about what's happening outside. All the physics are exactly the same. And the next one is special relativity. This is one of the famous theories of Albert Einstein. And here we've got the ladder paradox, which explains how if a ladder is moving at a very fast speed, its length will contract. So even though it's should be too big to fit in this garage, when it's moving at a fast speed, it becomes shorter, and therefore it can fit into the garage. Okay, and the next lesson is about equivalence and unification. Here at the top you see space, time, energy, and matter. And Einstein showed how space and time can be unified into the space-time continuum. He also showed how energy and mass are equivalent to each other. So now scientists are trying to unify both of those space-time and mass energy into one mass energy space-time. Okay, so the next lesson is about Advaita Vedanta, which is the philosophy of quantum theory. And you see here you've got two trees. One of them is fallen over, and the other one's saying, "I heard that." This is a reference to the Buddhist Zen Buddhism question. If a tree falls in the forest and there's no one there to hear it, does it make a sound? Does it? Okay, quantum entanglement. So here we'll look at how the measurements on one particle are related to the measurements of another particle, even if those particles are separated by a very long distance. So they seem to be informing each other, or to have some relationship with each other, which is described by Bell's theorem, which is a mathematical idea which we will look at in this lesson. So the next lesson talks about the wave and particle nature of, say, light. This is a picture of the double slit experiment, where if you turn on a light and you've got two holes in a partition at the back of the wall, you may see an interference pattern where you see more than two bars of light, because light is acting like a wave which interferes with itself. And finally, the most difficult lesson, non-chronological reasoning. And you see a picture of time with a cross through it. No, there's no time. There's no such thing as time in Vedic thought. So there's no causation. And we can show this by seeing how simultaneity is relative and how we can travel through time. So in this lesson we'll learn how to reason, explain the causes or reasons for a phenomenon without talking about time. Okay, so that's the end of this presentation, and I hope to see you in the lessons. Thank you.